Welcome back after our extended break. As you know, things are going to be a little bit different for the rest of the course here. So basically, with these online lectures, these probably won't go necessarily as long as our classes would because there's going to be points in here where I suggest, hey, why don't you take a few minutes and practice this? Or, I'll say, okay, you guys should practice these problems from your work, kind of like we would do with in-class practice. So in addition to giving you these lectures to watch, I'm also going to be giving you a few other resources and things, some PowerPoints at some point and whatnot to look at. But I will keep you guys up to date with all the stuff that you should be doing. And hopefully, if there's any issues, we can get them resolved quickly. But do feel free to ask me any questions that you want to. Obviously, you won't be able to ask me any questions as I'm lecturing like you normally would be able to, so that's unfortunate. But you can always email me, come talk to me over Blackboard Collaborate during office hours and things, and hopefully I can answer any questions that you have. All right, so today, what I would like to start talking about are units and unit conversions. So that's really going to be the topic of what I want you guys to focus on for this week, is understanding units, how to use them, how to convert between units, and all this sort of thing. So first of all, what is a unit and why do we care? Well, you probably know what a unit is, or at least I'm sure that you know some examples of units. For example, inches are a kind of unit. Centimeters are a kind of unit if you are, using the metric system. Pounds, that's another kind of unit. We use pounds to measure weight. We use ounces to measure weight. We also use, in the metric system, they have kilograms and grams. And then, of course, we have a lot of other types of units as well that you can probably think of. Different units are used to measure different things. And the reason that we need these units is because if I just give you a number, in mathematics, a number can make sense. But when we're talking about things sort of in the real world, if I just give you a number, you kind of need to know what that number refers to. We need some kind of reference. If you ask me, well, how much does this patient weigh? Maybe you have a dog. How much does it weigh? If I just tell you 20, what does that mean? It doesn't mean anything in and of itself. You need some kind of a reference. You need to be able to say it is 20 of this particular unit in weight. So maybe it's 20 pounds. Okay, so that would mean we have this standard reference of, okay, this is the weight of what we call 1 pound. And this dog weighs 20 times that amount. But maybe I mean it's 20 kilograms. And that's something completely different than being 20 pounds. And this is why you need to have units. Another term for these units sometimes is dimensions. So you may see that term thrown around sometimes as well. Although strictly speaking, dimensions refers more to the type of thing being measured. So for example, kilograms and pounds, these are for measuring weights. Inches and centimeters, these are for measuring lengths. Square feet, square meters, these would be units that you actually use to measure the area of something. So maybe you're talking about, okay, you're putting together a house, you want to paint a room, and you want to know how much paint do you need. Well, you measure the walls and you say, okay, we need to cover 800 square feet of walls with paint. So how much paint are we going to need? Other types of units that you might think of would be things for measuring, say, volumes of liquid. For example, you can have liters or quarts or pints and things like that. Now, your book has a list of various units and what they mean and how to use them. So I will not write down all these different units up here. But what I am going to do is I want to talk about if you have something in one kind of unit and you want to convert it to a different kind of unit, how can you go about doing that? Well, the answer is that different units, if they measure the same type of thing, and this is important, they have to measure the same kind of thing, otherwise it doesn't make sense to do a conversion between them, then we can equate some quantity of one unit with some quantity of another unit. And a good example of this, and the one I want to start with because the numbers work out kind of nicely, is let's suppose that we want to talk about lengths in meters, which are represented with the unit symbol m, versus lengths that are measured in centimeters. And the symbol for centimeters is cm. So if you think back to what we said about Roman numerals, you'll recognize that C. Now, these are both units for measuring lengths. So it makes sense to compare them. And the comparison between them is that 1 meter is equal to 100 centimeters. So if I have something that I measure to be 1 meter in length, that comes out to be 100 centimeters in length. If I have something that comes out to be 100 centimeters in length, then that is the same as something 1 meter in length. Okay, so hopefully that makes sense to you guys, and that's pretty straightforward there. Now, of course, you could also ask, well, what if we wanted to give the length in inches or feet or something like this? And yeah, you could do that kind of thing too, and we'll talk about that in a little bit. But for now, I want to just think about these two units. I want to think about the meters, and I want to think about the centimeters. Now, from this relationship, we can say that the unit meters is equal to 100 centimeters divided by 1, or we can say that 1 centimeter is equal to 1 meter divided by 100. Another way of thinking about this is that, and I'm going to have to just write this up here so that I don't have to erase anything. Unfortunately, my whiteboard setup here is not really optimal, but it's what I have to work with. So another way of thinking about this is that 100 centimeters divided by 1 meter is equal to 1, and that's also equal to 1 meter over 100 centimeters. These units act just like any other number or variable or constant. So what that means is that if I see them showing up in some kind of an expression, I can cancel them and multiply them just like I would with any other kind of constants. And I can use that in order to do conversions. So let me show you how you could do that. Let's say I want to convert 5 meters to centimeters. Now, you could probably figure this out just by thinking about it, right? If 1 meter is 100 centimeters, how much would 5 meters be? Well, it would be 500 centimeters, right? Because we have 5 copies of 100 centimeters. So that one's pretty easy to do. But I want to show you a different way of thinking about it that it might seem like, well, why do we need a different way to think about it? The reason is because later on, we're going to be dealing with some situations that are maybe a tad more complicated or that involve conversions that aren't quite so intuitively obvious. And at that point, this new way of thinking about it is going to be really helpful. Well, the way that I can think about this is we want to cancel the meter unit, and we want to get the centimeter unit. If I start with 5 meters, remember, one thing that you can always do to a quantity is you can multiply it by 1, and that does not change the quantity. So if I take, say, 8 times 1, that's still 8. If I take -3 times 1, that's still -3. And if I take something that has units and I multiply it by 1, I don't change the actual value of the quantity. If I multiply this by 100 centimeters over 1 meter, then the meter units cancel and the centimeter unit remains. And I get 5 times 100 over 1 in meters, and this comes out to, I'm sorry, in centimeters. I'm apparently looking at the wrong thing here. I get 5 times 100 centimeters, which comes out to be 500 centimeters. Okay, exactly what we would sort of get if we just thought about this directly. But I want to focus on the method that we use, because this is the method we're going to be using in more complicated situations as well. So the method that we used here is, I looked at this and I said, okay, I want to get rid of this unit of meters and I want to get a unit of centimeters. Well, if I want to do that, then I want to multiply by 1 in such a way that there's a meter in the denominator and a centimeter in the numerator. Oh, hey, I have that right here. So I multiply by that factor, and it cancels the meters and gives me centimeters. Now, we could go the other direction as well by a similar kind of reasoning. So let me write down this problem, and then I want you guys to pause the video, take a minute to try to solve it on your own, and then you can unpause and see whether your answer agrees with mine. So let's say if you can convert 35 centimeters to meters. So pause it, and we're back, hopefully. So I'm going to do the same kind of idea. I want to cancel centimeters and get meters. So which one of these do you think I should use? Well, if I want to cancel out the centimeters, I need centimeters in the denominator. That's what I've got over here. So we're going to take 35 centimeters and multiply this by 1 meter over 100 centimeters. Okay, the centimeters cancel. This is very similar to what we saw happen in our previous example. The centimeters cancel, and they leave me with meters. So I have 35 over 100 in meters. Now, there's 2 different ways that you could go about writing down the final answer. You could either write this as, let's see, if I divided everything by 5, I could say this is 7 over 20 meters. Or I could just say this is 0.35 meters and write this out in decimal. A lot of times when you're working with lengths like this, you're probably going to want the answer in decimal. Unless I specify, I don't really care which way you guys do it. So do whatever you're comfortable with. I do want you to either convert it to decimal or give it to me in a reduced form, of course. I don't want to see any non-reduced fractions as your final answer. It's not a big deal, but you really should put it in reduced form or in decimal. Okay. Now, of course, this idea works with any kinds of units that measure the same kind of quantity. So let's take a look at something that's a little bit different. Let's say that we are dealing with weights. Well, one way to measure weight is in pounds, which has the symbol LB, and don't ask me why. This is some crazy British thing that came around, and they gave us this LB symbol for pounds. I really have no idea where it came from. And then we have ounces. And ounces is OZ. Again, why is it OZ instead of OC? I don't know. But these are the symbols that we've got to work with, so I'm not going to change them around. Now, the relationship here, which you may remember, is that 16 ounces is equal to 1 pound. Well, this gives us a couple of nice relationships here that are all equal to 1, or I should say ratios, not even relationships. They are relationships, but in this case, they're relationships that involve ratios. Okay, so 16 ounces over 1 pound is equal to 1, and the reciprocal of that, or just dividing the other way, gives me that 1 pound over 16 ounces is equal to 1. Now, these types of ratios that I've got here, these are called conversion factors, because they are these things that allow us to convert between different units. They are factors that tell you how do I convert between pounds and ounces, or ounces and pounds? So let's write down an example using this particular kind of unit. So let's say that we want to convert 3.5 pounds to ounces. Now, this is the kind of thing that you might have to really do a lot as a veterinary worker, okay? This is the sort of thing where maybe you have a patient comes in, you know the weight of the patient because it's on the chart, but it's on the chart in pounds. It says 3.5 pounds. You need to figure out how much medicine to give this animal. Well, maybe the medicine tells you how much medicine in terms of the ounces of the animal. So you need to figure out, how do I get the weight of the patient from pounds into ounces? I made that sound really complicated, but as we'll see, it's really not that complicated. I'm just saying it's the kind of thing that you may actually be doing on a pretty regular basis. Okay, so how do we do this? Well, it's just like with the last kind of problem where we were working with the, what was it we were doing? Centimeters and meters. I've already forgotten what happened 10 minutes ago. Centimeters and meters. In this case, it's just pounds and ounces. What do I want to cancel here? I want to cancel the pounds. And I want to end with ounces. That means I want ounces in the numerator because I'm ending with that. I want pounds in the denominator because I want to cancel that. Well, that's what I've got right here, right? I have ounces in the numerator, pounds in the denominator. So, 3.5 pounds, and I do apologize that it's very hard to see when I'm standing between the board and the camera, but I can't write without doing that. 3.5 pounds times 16 ounces divided by 1 pound. The pounds will cancel. In fact, we picked this factor because it cancels the pounds. If that didn't happen, that would mean you picked the wrong factor. You should go back a bit and rethink what it is that you're doing. This gives me 3.5 times 16 divided by 1, and of course this is going to be in ounces. So what is this going to come out to be? Well, this is going to be 3 times 16 would give me 48, and 0.5 gives me 8. So 48 plus 8 is 56. So we get 56 ounces as our final answer. Okay, now, if you're getting tired of watching this, maybe take a little break for a minute and maybe practice a few of the problems in your book. I'll mention which problems to do online. And then, now let's take a look at some slightly more complicated examples here. Now, in order to introduce these more complicated examples, I want to introduce the idea of converting between lots of different units. So just as an example, let's do inches, feet, and yards. Now this is going back to lengths. The symbols for each of these: inches is abbreviated as IN, feet is abbreviated as FT, and yards is usually abbreviated as YD, or sometimes people put YDS, whatever you want to do here. YD is fine for yards. What are the relationships between these things? Well, what we know is that 12 inches is equal to 1 foot. We also know that 3 feet is equal to 1 yard. And from this, I can compute my conversion ratios, because this tells me that 12 inches over 1 foot equals 1, and that's also equal to 1 foot over 12 inches. From the feet and yards equation that I have, I get 3 feet per 1 yard equals 1, and that's also equal to 1 yard per 3 feet. So again, I've got these conversion ratios here. Now, by the way, before we go on to some examples, I should mention, excuse me for a moment. All right, we are back. Sorry about that. So I should mention for a moment here that I want you guys to be able to figure out these conversion ratios if you have an equation like this. So if I tell you 12 inches is equal to 1 foot, you should be able to write down these kinds of conversion ratios. What are the ratios that are equal to 1 in this instance? Now, what if I had something that is in inches and I want to convert it into yards? So let's say that I want to convert 18 inches to yards. Now, there's a couple of ways of doing this, and I want to show you sort of the slightly longer way first. The reason I want to show you this longer way is because even though it's slightly longer, it's going to be a way that you're going to use an awful lot, because in general, you often have to do conversions where you use multiple conversion ratios. Now, when we do that, we'll also notice here that actually you could kind of use these conversion ratios. You could get one single conversion ratio to go straight from inches to yards. But I want to show you how you can do it in multiple steps because it's going to be very useful for other types of problems. So one way I could do this is I could say, I'm starting with 18 inches. I would like to cancel the inches. I would like to end with yards. Well, I can't just do that directly because I don't have anything that has inches in the denominator and yards in the numerator. But what I do have is inches in the denominator and feet in the numerator. So let us proceed boldly ahead and multiply by that and see what happens. We're going to hope for the best. That will cancel out the inches units. Now, the problem is that leaves me with units in feet, and I don't want units in feet, do I? I want something else. I actually want yards. But you can probably see what's going to happen here. I'm now going to be able to multiply this by 1 yard over 3 feet. That will cancel out the feet units and leave me with yards. So we multiply by 1 over 3 feet. I'm sorry, 1 yard over 3 feet. The feet units now cancel. This leaves me with 18 times 1 times 1 over 12 times 3 in yards. This is going to come out to be 18 over 36 yards, which is 1/2 yard, or if you want to write it in decimal, you can write that as 0.5 yards. So either of these answers is fine. You don't need to write both of them. Just write whatever you're comfortable with. Again, 18 over 36, this is correct, but I would like it if you guys would put it into a reduced form. Putting it in a reduced form, it's just good practice. It makes it much easier for anybody who comes along afterwards and has to read what you've written. So if I were, say, writing this down because I want to tell somebody, hey, what I need is 1/2 yard, it's much nicer for them if I tell them 1/2 yard instead of 18 over 36ths of a yard. So we were able to do this by using multiple conversion ratios here. Now, you could, if you wanted to, work out a single ratio here that would give you inches to yards, because you'll notice that what we really did is we multiplied by the 1 foot over 12 inches times 1 yard over 3 feet. And if I just took 1 foot over 12 inches and I multiplied this, that is a terrible multiplication symbol, by 1 yard per 3 feet, well, this right here is equal to 1. This right here is equal to 1. What is the product of 1 times 1? It's 1. So this is actually still equal to 1. Why did I put... No, that is what I wanted. Yes, excellent. Everything is working out exactly as intended. The reason I want to write it this way is because the feet now cancel, and I am left with... I'm going to erase this here. I hope you guys have notes. By the way, you guys should be taking notes kind of like you would in a lecture. And the reason you should be doing that is not because I'm just trying to be hard on you or make you do extra work. It's because, and my wife, who is a psychologist who knows quite a bit about learning and memory, confirmed this for me. Taking notes helps encode things in your memory. So you actually remember something better when you write down notes of your own than if you just listen to me talk and read the book. The act of actually going through that process of writing it out will make you remember it better. Okay, so returning to the problem at hand, which is about this conversion ratio, what we get then is that 1 yard over 12 times 3 inches is equal to 1, or 1 yard over 36 inches equals 1. And by taking the reciprocal here, we also get 36 inches over 1 yard. So if we wanted to, we could say, if we're going to do a lot of conversions between inches and yards, we may as well go ahead and say, let's just once for all figure out the conversion ratio for inches and yards, and then we'll use it every time. The reason I wanted to show you the longer way first is because there's going to be instances where you have to do a new unit conversion, a sort that you don't normally have to do and that you may never have done before. And I want you guys to know how to build a new unit conversion out of the unit conversions that you know. That's a very important skill to be able to have. Let's take a look at another kind of situation where you might see this kind of thing. Now, this is one where I'm going to show you guys the setup, but I'm going to leave it as a little bit of an exercise for you guys to get the final answer. Part of the reason for this is because really getting the answer in this case, you probably just want to use a calculator. So I'm going to leave it to you guys to enter into a calculator. As you know, I don't normally carry a calculator with me, and today is no exception. So let's suppose that we want to convert 4 meters to feet. Well, I haven't really told you all the conversion ratios that we need for this sort of thing, but if you look in your textbook, you will find conversion ratios that we could use for this. The conversion ratios that we're going to want to use is we have that, sorry, that's the upside down of what I want. 100 centimeters per 1 meter is equal to 1. We also have a conversion ratio that says that 1 inch per 2.54 centimeters is equal to 1. And finally, we have one that says that 1 foot per 12 inches is equal to 1. So what we're going to do here to do this conversion, whoops, I wrote convert, not convert, my apologies. What we're going to do is, just like the previous example, I'm going to chain these together. And I'm going to start by saying, how do I cancel out the meters? Well, I can cancel out the meters using this first ratio. So I take my 4 meters and I multiply by 100 centimeters divided by 1 meter. Okay, that cancels my meters. Next, it leaves me with centimeters, but I ultimately want feet. So how can I get rid of the centimeters? Well, I can use this second ratio here because that has centimeters in the denominator, and that will at least get rid of the centimeters. So I multiply by 1 inch over 2.54 centimeters, and there we go, centimeters gone. Okay, now I need to get rid of the inches because I really want feet. But at this point, I can actually get to feet because I can cancel the inches and end up with feet using this last factor. So we get 1 foot per 12 inches multiplied on there, and it cancels out the inches. So now, notice that we have our units, they get kind of canceled in pairs. So the meters cancel, then the centimeters cancel, and then the inches cancel. The only one that doesn't cancel out here is feet. So let's write down what we get. We end up with 4 times 100 divided by 2.54 times 12 in feet. And that is going to be 400 divided by 2.54 times 12 in feet. Now, at this point, I'm going to say, honestly, just do this with a calculator and get the answer. So I will leave it to you guys to plug that into a calculator and see what you end up getting. All right, so give me one moment here to grab my textbook so that I can tell you guys what problems you should be practicing for this week, and then I'm going to end this lecture here. All right, so I would like you guys to take a look at pages 141 to 145 of your textbook and try to practice those problems. Now, unfortunately, I can't be there helping you guys practice in class, but if you do have questions, email me or come to my office hours, or we can set up a time to meet using Blackboard Collaborate that isn't during my regular office hours. I'm happy to schedule, individual or small group meetings with you guys outside of that time if I'm available and you're available at those times. So try to do those problems. On Thursday, we're going to try to talk in more detail about the way the metric system works, because the metric system is very convenient. Everything kind of works the same in it, and there's a kind of fairly simple set of rules that you can kind of just memorize, and then you understand everything about the metric system. The imperial system, which is more common in America in sort of common usage, unfortunately doesn't have those kinds of rules. So I don't know whether in veterinary circles it is more common to use metric or imperial, but it's good to know how to do both, because sometimes you're going to need both, and at the very least, it's going to give us practice with conversions and things, even if it turns out to be a form of unit that you don't use as much. All right, so I will be posting another lecture Thursday, and in the meantime, have fun practicing, and I hope you guys stay safe.